Hello, ladies and gentlemen. This is section 7.9 of Mrs. Quinn's geometry class. And today we're going to talk about angles. Exterior angle definition says an angle that is exterior to a polygon is exterior if and only if it forms a linear pair with one of the angles. You can see I've already extended this line right here. Would you agree that 2 and 4 form a linear pair, meaning their sum would be 180? I could have drawn an exterior angle here with 3 and labeled it angle 5. Notice how 3 and 5 are linear pair. When we say exterior angle, that's what we mean, an extension of one of our lines that leads to a new angle. And so example, right here I have exterior angle number 2, and I could find that because these 3 angles right here have to add to be 180. Do you agree? So I'm going to take 180 and I'm going to subtract 82 and 51, and I end up with an angle of 47 for angle 1. So to find the measure of angle 2, we're going to have to get a theorem or inequality for that, and I will give that to you next. The exterior angle theorem says in a triangle, the measure of an exterior angle is equal to the sum of the measures of the interior angles of the other 2 vertices. So I could add these together and get my measure of angle 4. Notice that right here, we actually could have found angle 2. I spoke too soon. These 2 angles are a linear pair by definition. And so hopefully you will agree that if I took 180 minus 87, I should end up with a measure of angle 2. So 180 minus 47, and I get the measure of angle 2 equals 133 degrees. Now we have a theorem that says the opposite 2 angles, if I add them together, that has to equal the measure of angle 2. So let's find out. If I take 82 degrees plus 51 degrees, does that equal 133? Yes, indeed it does. So you have 2 ways to find the measure of an exterior angle. You know that it's a linear pair with this one, so you can subtract this measure from 180, or you can add these 2 together, and that's going to be the measure of your exterior angle. For this one right here, if this is my exterior angle M, I would have to add angle X and angle Y together to find measure of angle M. Does that make sense? All right. We already did this one. For the exterior angle inequality, in a triangle, the measure of the exterior angle has to be greater than each of the other 2 angles of the vertices. So that just means that the measure of angle 4 has to be greater than the measure of angle 1. And the measure of angle 4 has to be greater than the measure of angle 2. The unequal side theorem. If 2 sides of a triangle are not congruent, then the sides opposite them are not congruent. And the larger angle is always opposite the larger side. So that means since this is my longest side, I would expect this to be my biggest angle. This is the next largest side, so I'd expect this to be the next largest angle, and this smallest side would be across from the smallest angle. Now, these dash marks don't mean biggest and smallest. I just did that so that you could see the comparison. Largest, medium, and smallest. Let's look at an example right here. If this angle is 45, this angle is 50, and this angle is 40, my longest side length would have to be X right here, across from 50. My smallest side length would have to be Y across from the 40. And the one that's in the middle would be W across from 45. All right? Unequal side lengths. If 2 angles in a triangle are not congruent, then the sides opposite them are not congruent. And the longer side is always opposite the larger angle. So here, Since I have 3 unequal angles, that means this triangle is scalene, and each side length is different. Your longest side length has to be across from the biggest angle. The smallest side length has to be across from the smallest angle, and this one would be in the middle. All right, for tomorrow, list the angles from smallest to largest. Look at X, Y, Z and figure out from your side lengths which ones would be the longest, smallest, and which one would be the middle. And then list them from smallest to largest, and I will see